Okay, tonight I'm going to get on one of my soapboxes here. What I was doing was I was going through a practice exam for one of the my dev certs, and it doesn't really it doesn't really matter which practice engine I was using. But the point is I came across a question, and they gave their solution, and I'm not really so sure that I like it as much. So again, this is my soapbox. So I'm gonna explain the question to you, and I'm gonna show you their solution. Then I'm gonna show you how I made it better. And this is the reason why I think exams are unrealistic a lot of times, because the more you know, the less good they actually do you, and the more problems you find with the solution. So I really have to wonder who's writing these solutions a lot of times. Here, I'll show you what I mean. So, oh, yeah, don't show the message again. Okay, so it starts off with defining a table, and the point is you're going to build a function to return something from this table. So you've got the product ID, and what we're concerned with here is the product ID and the reorder point. So what you're going to do is you're building a function that searches for a product ID, and if the product ID is between a certain range, then you're going to return the reorder point. Otherwise, you're going to return 0. So if you look down here at their solution, and this is their exact solution right here, they create the function, they pass in the product ID, right? And it returns int. We'll talk about that in a minute. And so the first thing you do is you declare a variable for reorder point, and then you select reorder point equals reorder point from product details, which is our table up there, right? So I'm selecting that to equal that, where product ID equals the product ID you passed in. So very simply, what it's doing is you're passing in the product ID, and then you're searching for the reorder point for that product ID, and you're assigning it to this variable. That's pretty easy, right? So once you've got the reorder point for the product ID, you're saying the product ID I passed in, if the product ID I passed in is between 1 and 500, or 100 and 500, right? Then return the reorder point that I just looked up. Otherwise, return 0, right? So you're saying go get the reorder point and return it if the product ID is between 100 and 500. If the product ID I passed in isn't between 100 and 500, then return 0. And that's the solution to the question that they have in the dev exam, right? So the problem I have with this, obviously, is it's not a good production function, because no matter what happens, you're going to query that table. And that's just not a good solution. What you want to do is you want a solution that only queries the table when it needs to. And that's going to be that could be a big deal. I'll talk about that more in a minute. I'm going to try to keep this short, right? So here's the function I created, and all I did was alter it just a little bit. So I've got it get reorder point 2, right? I pass in all of the same things. Everything is the same, except right after the declare here, I compare. I say if the prod ID that I passed in up here, right? If this is between 100 and 500, then select reorder point, or v reorder point, to equal the reorder point from the table. Otherwise, return 0. So, really what I'm saying here is instead of querying the table and then checking the value, why don't you check the value first and only query the table if you need to, right? Otherwise, this function is going to be really fast, right? If you do anything other than values between 100 and 500, this thing's going to return instantly, and it's never going to touch the disk at all. And that's going to be really important. Now, there are a couple scenarios where this is really important, and these scenarios are, one, if this function gets called a lot. Now, let's say that you know, this doesn't take up that much CPU, let's say, or that much disk. Let's say it's an indexed column and it's a really, really fast read, right? Which is going to probably be the case, hopefully. But this thing gets called anywhere between, you know, 100 and 1,000 times a minute, right? Which I've actually been in production environments. I was in a scanning environment where we had almost an entire warehouse full of high-speed IBML scanners, and we had some SPs that were running 5,000 times a minute. That's several hundred times a second, right? I mean, that's incredible. I mean, that's a lot of SPs. So, you know, when you're tuning these things, and actually, I was able to tune one of these things when I was and increase the performance of the server several times over, because everybody looked at Profiler and they said, oh, well, this is returning in a decent time, and I made a change that improved the performance by only like 1/100th of a millisecond. But as many times as that was being called, that made all the difference in the world. So that kind of thing really helps. Another instance where that would be really, really helpful, other than being called several times a second, right, is let's say that this is an inline function that you're doing in a query, and it's being called for every single row, and you're pulling this thing back for, say, a few 100,000 rows. You know, I mean, if you query the table every single time for every single row, you're querying that table several 100,000 times, versus maybe just, you know, a few dozen times, or, you know, a couple thousand times, or 20,000 times. You know, you could cut that by 90%, right? And your query is going to take a lot less time if it doesn't have to query the table for every single row. So here, I wanted to show you this. I've got 2 million rows in this table that I just generated with Redgate's data generator, right? Love that thing, by the way. And I'm querying on 1 million. It doesn't really matter. So I'm using ID 1 million. You can see that it's, or actually, I don't want to do 1 million. I want to do 100, because I want to do something that's actually going to fall inside, huh? So for theirs, and here I'll show you here my profiler right here. I'll start it. Okay, good. Let me clear that. Let's get all that crap out of there. Okay, so I'll execute, and I got a 7 back. Excellent. And stop. Good. So I come here, I can see here, there it is, where I selected from there, and it took 312 CPU. Right? That's great. Where am I? Here I am. And if I do mine, get over here. And if I do mine, it'll be the exact same thing. Come here, you. Let me wipe that. Do that, it'll execute. Give me the 7. Huh, didn't start. Start, there we go. Execute. I get the 7. And I should get about the same thing. And where is it? There it is, 313. But that's close enough, right? So I'm going to clear that. Now let's say I choose something. Let's choose 501. And 501. Let me make sure this is started real quick. Yep, let me clear some of the stuff out of there so it makes it easier to see. So that returned 0. But you notice here, not only did it return 0, where did it go? Let me pause that. Not there. There it is. So I still had 21,000 and change in reads, right? Still had to read the table. No matter what, it still had to read the table. Right here, you see the select from prod details right there. Okay, so let's start that. Let's clear that. Let's run this one, same value. Execute. Back over here. And you'll see here, nowhere do you see any more than a couple reads, and you never ever ever see it hit the table. There is no place here where it hits the table. So you can see that if this thing is being called, if this is an inline function and it's being called for every single row, you're going to save yourself a ton of reads and a lot of CPU actually. Or if it's being called individually, say several thousand times a second, or I mean several thousand times a minute or several hundred times a second, which don't laugh, that's very common, then you're going to save yourself tons of CPU. So, and tons of disk, right? So that's one of the things that really upsets me about exams, though, is they never take real production scenarios into account, and you end up with these BS solutions here that are only half-assed at best, and you know, and you do with it what you can, right? But I want to show you guys this so that you, when you're designing your functions and you're doing stuff like this, think of this. Think of ways to keep it from hitting the table if it doesn't need to. Don't make it hit the table every single time and look up a value just because you can, just because it's easier. Take the high road. Be a good developer. Be good to your systems, and only and design things to only hit the tables when it's necessary. That's all I got, guys.